Hello, this video is going to look at two more examples of how to find the derivative of a function using the limit process. So we have the function f of x equals 1 minus x squared, and if we want to calculate the derivative, we need to take the limit of f of x plus delta x, and again that means we're going to take all of this and substitute that in for x. So we're going to get 1 minus, and be careful here with the negative, so we have parentheses x plus delta x quantity squared minus f of x. So we're going to subtract away the whole function, so that's minus brackets 1 minus x squared. And once again, in order to find the limit, we need to get the delta x off the bottom. So therefore, we need to simplify or cancel out the numerator, or simplify the multiply out the numerator so we can cancel out the delta x. So we have 1 minus, and once again, be careful, x plus delta x squared. That means you have to FOIL this out. So you're going to end up with x squared plus 2x delta x plus delta x squared. Now keep in mind that means you're going to take x plus delta x times x plus delta x, and you're going to have to FOIL this out. So you're going to have to take x times x, and then you're going to take x times delta x times x, and that's where we get the 2x delta x. And then, of course, delta x and delta x gives us the delta x squared. And if we distribute the negative sign now for the last part, we get negative 1 plus x squared, all divided by our delta x. And once again, we're going to distribute the negative, so we get 1 minus x squared minus 2x delta x plus delta x squared minus 1 plus x squared. And do you notice what cancels? 1, negative x squared, positive x squared. And I'll show you in just a minute, but do you realize what's canceling out here? If you look back at the other examples we've worked out, what's always canceling? And I'm not going to tell you just yet, but I'm going to see if you can kind of find out the pattern here. And once we go through the other examples here, I'm going to indicate what's happening that's going to cancel out. So we're left with the negative 2x delta x plus delta x squared. And I know I'm writing down every step here, but you need to be careful so that you don't make a mistake. At this point, we're able to once again factor out a delta x, and that's really what we're trying to do. We're trying to get to the point where when we cancel out the numerator, the only terms left contain a delta x, so therefore we can factor out the delta x. And if we factor it out, we're left with a negative 2x plus delta x. And the advantage, or the reason we want to factor this out, again, so we can cancel the delta x off the bottom. And now we're left with negative 2x plus delta x, which, because we've canceled the delta x off the bottom, we simply now can use our direct substitution. So we would have negative 2x plus 0. So we end up with a negative 2x as our derivative. Now, notice here In the previous videos, we had a couple examples where we were looking at the derivative of straight lines and we ended up with a constant. Well, now we're taking the derivative here of our function 1 minus x squared, which is a quadratic function where we know the graph is going to be a parabola, and we know that the slope is going to constantly change, so therefore our derivative is going to be changing, so therefore the slope is going to be changing throughout the graph. We end up with a negative 2x. All right, the next example, let's say that we have the function f of x equals the square root of x, and we want to find f prime of x. All right, once again, I'll write it down one more time here. The formula for finding the derivative. So if we want to find the derivative, once again, f prime of x, we're going to take the limit, and we need to find first f of x plus delta x. So again, we're going to plug all of that in for the x here, so we would have the square root of x plus delta x minus the entire function. So that's minus the original function square root of x. Now, how can we simplify this so that we can cancel this delta x off the bottom? Well, for this example, we're not able to simplify the numerator by combining like terms. So for this example, we're going to have to do something a little different, and this is where we're going to multiply by that conjugate. So we're going to multiply by the square root of x plus delta x plus the square root of x on the top and bottom. So now when we multiply on the top here, we get square root of x plus delta x, square root of x plus delta x. That's going to leave us with just simply x plus delta x. The square roots are going to cancel each other out. And then notice what's going to happen when we multiply here and here. We're going to get a positive square root of x multiplied by the square root of x plus delta x, and then we're going to get a negative square root of x times the square root of x plus delta x. So that middle term here, they're going to cancel each other out. So therefore, we're simply going to multiply a negative square root of x and a positive square root of x, and we would be left with simply negative x, because once again, the square roots are going to cancel out. Now, on the bottom, once again, do not distribute here. We just want to leave this as factored. It'll make things a lot easier, and I think you'll see why we don't want to distribute the delta x, because now in the numerator, once again, our x's are going to cancel out. And we're simply left with a delta x on top. And on the bottom, we have our delta x multiplied by the square root. And once again, our delta x's will cancel out. So we're left with 1 divided by the square root of x plus delta x plus the square root of x. Now we've accomplished our goal. We have got the delta x is canceled off of the denominator. So we can once again use our direct substitution. And you notice there is a delta x in the denominator, but it's going to be the square root of x plus 0 plus the square root of x, which means we would end up with 1 over the square root of x plus the square root of x, which would be 1 over 2 square root of x. And this here is your derivative. And once again, because we know the graph here, f of x equals the square root of x, if you recall the graph of our original function, we have our graph here. This is the square root of x. And clearly, the slope is constantly changing. So if we want to find the slope at any point here, just like before, all we need to do is find the x value of the point and plug it into the formula. Now, let me go back up here. I mentioned before, have you seen a pattern once we simplify the numerator? Well, if you notice in our formula up here, I've been circling the first part of our formula with blue, the second part in green. Once you plug in and evaluate the function using this slope formula, the part that is in blue, once we simplify this, should cancel out everything that's green. Because if you look at the part that's green, the green part is the original function we're subtracting away. And this original part that we're subtracting away, these terms do not contain a delta x. So kind of the goal here is we want to cancel out all of the terms that do not contain a delta x. So therefore, we can factor the delta x out in this step here. So this is one way that you can kind of check to make sure that whether you made a mistake or not. If you're working through a problem and all of a sudden you realize that one of these terms over here in green, the original function part, doesn't cancel out, then you know somewhere you've probably made a mistake with one of your signs. So go back and look, because everything here in this second part, again, should cancel out. Just like the -1 and x squared cancels in this example. And in the next example, once we finally simplified this, this was a little bit different because of using the multiplying by the conjugate. But once again, if you notice here, the x's do cancel out. So again, that part should always cancel. If not, go back and see if you didn't make a mistake with your positive and negative signs.